SoftBank to acquire chip designer Ampere in $6.5 billion deal. Key points. SoftBank Group said Wednesday that it will acquire the Ampere Computing, a startup that designs an ARM-based server chip for $6.5 billion. Carlyle Group and Oracle both have committed to selling their stake in Ampere, SoftBank said. Ampere will operate as an independent subsidiary and will keep its headquarters in Santa Clara, California, and the statement said. The logo of Japanese company SoftBank Group is seen outside the company's headquarters in Tokyo, January 22nd, 2025. The SoftBank Group said Wednesday that it will acquire Ampere Computing, a startup that designed an ARM-based server chip for $6.5 billion. The Japanese giant expected the deal to close in the second half of 2025, according to a statement. The Carlyle Group and Oracle both have committed to selling their respective stakes in Ampere, which will have operate an independent subsidiary and will keep its quarters in Santa Clara, California, according to SoftBank. The Ampere's expertise in semiconductors and high-performance computing will help accelerate this vision. It deepens our commitment to the AI innovation in the United States, SoftBank Group Chairman and CEO Masayoshi Son was quoted as saying in a separated statement. So the startup has 1,000 semiconductor engineers, SoftBank said. SoftBank has been broadening its investment in AI infrastructure, including partnerships with OpenAI announced last month to create enterprise-level AI, and through its involvement in U.S. President Donald Trump's $500 billion private AI investment project Stargate. So with the shared vision for advancing AI, we are excited to join SoftBank Group and partner with its portfolio of leading technology companies, said Lenny James, founder and CEO of the Ampere. This is a fantastic outcome for our team, and we are excited to drive forward our Ampere One roadmap for high-performance ARM processors and AI. The SoftBank acquired the British chip designer ARM in 2016 for $32 billion, with the company launching its initial public offering in 2023. Lenny James, the founder and chief executive officer of Ampere Computing LLC, speaks at the AI Pulse conference in Paris, November 7th, 2024. So the chips that use the ARM instruction set represent an alternative to chip based on the x86 architecture, which Intel and AMD sell. The ARM-based chips often consume the last energy. Ampere's founder and CEO, Lenny James, established the startup in 2017 after 28 years in Intel, where she rose to the position of president. The reading and cloud infrastructure provider Amazon Web Services offers a Graviton ARM chip for rent that have become popular among large customers. In October, Microsoft started selling access to its own Cobalt 100 ARM-based cloud computing instances. Okay, next article is how DeepSeek innovated large language models. Agree? The glimpse at how DeepSeek achieved its V3 and R1 the breakthrough, and how organizers can take advantage of the more innovation when they are emerged so quickly. The release of the DeepSeek is the role of the world of generative AI last month, leaving engineering and developers wondering how the company achieved what it did and how they might take advantage of technology in their own technology stacks. The DeepSeek team built on a development that were already known in the AI community but had not been fully applied. The result is a model that appeared to be comparable in performance to leading models like MetaLlama 3.1, but was built and trained at a fraction of the cost. Related more DeepSeek new analysis. Most importantly, DeepSeek released its work as open access technology, which means others can learn from it and create a far more competitive market for large language models, LLMs, and related technologies. Here's a glimpse at how DeepSeek achieved its breakthroughs and what organizations must do to take advantage of innovation when they emerge so quickly. Inside the DeepSeek models, DeepSeek released two models in the late December and late January. DeepSeek V3, a powerful foundation model comparable in scale to GPT-4, and DeepSeek R1, designed specifically for complex reasoning and based on the V3 foundation. Here's a look at the technical strategy for each. DeepSeek V3, used for precision training. DeepSeek leverages a bit precision metric multiplication for faster operation while implementing custom logic to accumulate results with correct precision. They also utilize the WGMMA parallel operators, pronounced Wangamama. I think it's a Japanese, the Wangamama. They're taking multi-token prediction to the next level. Clearly inspired by the Meta's French research team, which pioneered predicting multiple tokens simultaneously, DeepSeek enhanced the implementation techniques to push this concept even further. The expert use of the common language, the basic concept of the mixture of experts, MOE, is akin to activating the different part of the brain-based tasks, just as humans conserve energy by engaging only the necessary neural circuit. Traditional MOE models split the network into a limited number of the experts. For example, 8 experts, and activate only 1 or 2 per query. DeepSeek introduced a far more granular approaches, incorporating the idea originally explored by Microsoft Research and used to be processed by a model component that remained active at all times. DeepSeek R1, the reward reasoning at scale, much like AlphaGo Zero learned to play Go solely from the game rule. DeepSeek R1 Zero learns how to reason from a basic reward model. First, at this scale, while the concept is new, successfully applying it to a large-scale model is unprecedented. DeepSeek researchers capture some profound moments, such as the aha moment when the DeepSeek R1 Zero realized on its own that spending more time thinking leads to better answers. I wish I knew how to teach that. Curating the core start, the DeepSeek R1 model also leverages a more traditional approach, incorporating core start data from DeepSeek V3, while no groundbreaking techniques seems to be involved at this stage. Patience and meticulous curation likely played a crucial role in making it work. This DeepSeek advance is a testament to open research and how it can help the progress of humankind. One of the most interesting next steps, the great team at Hugging Face is already working to reproduce DeepSeek R1 in its Open R1 project. The importance of LLM agnosticism. The limiting factor for AI will not be uncovering business value or model quality. What is critical is that a company maintain an agnostic strategy with their AI partners. DeepSeek shows that betting on the single LLM provider will be a losing game. Some organizations have locked themselves into a single vendor, whether OpenAI and Anthropic or Mistral, but the ability of the new players to disrupt to landscape in a single weekend makes clear. Companies need an LLM agnostic approach. Multi-LLM infrastructure avoid the danger of the vendor lock-in and make it easier to integrate and switch between models as the market evolves. Essentially, this future-proof any LLM decision by ensuring optionality through a company's AI journey. Enterprises must also maintain control through careful governance. The DeepSeek and the fast emerging world of the agentic AI showed how chaotic and fast-moving the AI landscape has become. In a world of the open-source reasoning models and rapidly multiplying vendors, engineering teams will need to maintain rigorous testing, robust code reviews, and continuous monitoring. If you can meet these needs, technology like DeepSeek will be hugely positive for our business by increasing competition, driving down cost, and opening new use cases that more companies can capitalize on. The Florian Do is the co-founder and CEO Dataiku, the universal AI platform that provides the world's largest companies with control over their AI talent and process and technologies to unleash the creation of the analytics models and agent. Generative AI Insight provide a venue for technology leaders, including the vendors and outside contributor, to explore and discuss the challenging and opportunities to generative artificial intelligence. The selection is wide-ranging from technology deep dives to case studies, expert opinion, but also subjective based on our judgment of which topics treatment will best serve InfoWorld's technically sophisticated audience. InfoWorld does not accept marketing collateral for publication and reserve the right to edit or contributed content. Okay, thank you. The iPhone 17 said use MediaTek 5G modems instead of Apple C1 chips. Little is unknown about Apple's C1 chip. The company hasn't revealed much about its new 5G modem for iPhone 16e, but it seems logical to assume it might end up in more new iPhones models this year. However, reported by the typical reliable site information, the information paints a different picture as Apple moves away from its Qualcomm partnership. According to the publication, Apple doesn't plan to add the C1 modems to the iPhone 17 lineup. It will still move away from the Qualcomm, but MediaTek will be responsible for the 5G chips in these flagship phones. However, by 2026, Apple reportedly plans to add a C1 chip to at least one iPad, and they want to add the second generation of the C1 modems to iPhone 18 lineup. The information report corroborates a story by Bloomberg. Previously, the publication said that in the next year, this chip would finally add mmWave support and download speeds of 6 gigabits per second, 6 carrier aggregation when using sub-6 5G, and 8 carrier aggregation when using mmWave. When the iPhone reaches its 20th year anniversary in 2027, the company hopes it can top Qualcomm with its modern performance and AI features. Apple is also aiming to build support for next-generation satellite networks and eventually merge its 5G modem with its main processor, creating the ultimate singular mobile component. While we still have to see how Apple's C1 chip behaves in real-life usage, it's interesting how confident the company is about its new 5G modem and how fast it plans to move away from the Qualcomm. Another report by Reuters revealed that a C1 chip is so well integrated into Apple's ecosystem that it can dynamically look for the different networks or prioritize the connection you need depending on whether you want to send a file through AirDrop or look up something on the web. BGR will let you know once we learn about the Apple's 5G plan for the iPhone 17 and future devices. Okay, next one is NVIDIA said that DeepSeek advanced proof need for more of its chips. The U.S. microchip export control was designed for the freeze China's development of supercomputers used to develop nuclear weapons. The NVIDIA on Monday said China's AI firm DeepSeek's advances show the usefulness of the chip for the Chinese market, and then more of its chips will be needed in the future to meet demand for DeepSeek's services. NVIDIA issued a statement on a month after it shared tumbled 17% to $118.858 on investor concern that DeepSeek had matched rivals such as OpenAI using far fewer NVIDIA chips than U.S. firms. NVIDIA rivals advanced micro devices shared also slid more than 6% to $116.01. DeepSeek works illustrate how new models can be created using that techniques, leveraging widely available models and compute that is fully exposed to controlled component. NVIDIA said each statement, and one of the DeepSeek's research papers showed that it had used about 2,000 of the NVIDIA's H8 chips, which were designed to comply with the U.S. export control release in 2022, rules that exported to Reuters would barely slow China's AI progress. The U.S. microchips export control were designed to freeze China's the development of the supercomputers used to develop the unclear as weapons and artificial intelligence systems. Jamie Goodrich, a senior advisor to Rand for technology analysis, said there are also at least a dozen major supercomputers in China with significant numbers of NVIDIA's chips were that legal for purchase at the time that DeepSeek used them to learn how to become more efficient. Computing efficiency has also been a major focus of U.S. AI firms. DeepSeek didn't become nowhere. They have a model building 4 years, Goodrich, and it's been long known that the DeepSeek has a really good team, and if they had access to even more compute, God knows how capable they would be. DeepSeek was struggling on a Monday to accommodate the influx and new users. Servicing new users process that AI firms called inference, which NVIDIA said show that it's okay. Next article is the Bloomberg's ASML. Marvell develops custom HBM memory solutions interface sharing and higher performance on the menu. As Marvell had announced the custom high bandwidth memory CHBM solution for its custom XPUs designed for AI applications and Analyst Day 2024, developed partnership with the leading memory makers. CHBM promises to optimize performance, power, and memory capacity on die size and cost for specific XPU designs. CHBM will be compatible with the Marvell's custom XPUs and will not be a part of the JEDEC-defined HBM standard, at least initially. Marvell's custom HBM solution allows tailoring interfaces and stacks for a particular application. Through the company has not been disclosed any details. One of the Marvell's goals is to reduce the real-estate industry standard HBM interfaces occupied inside the processors, freeing up the real estate available to compute and features. The company asserted with its proprietary die-to-die I/O, and it will not be only be able to step back up to 25% more logic into the custom XPUs, but also potentially install to the 33 more CHBM memory packages next to compute chiplet to increase the amount of the DRAM available. The processor, addition to the company accepted to cut memory interface power consumption by up to 70%. So because Marvell's CHBM does not rely on a JEDEC specified standard on the hardware side of things, it will require a new controller and customizable physical interface, new die-to-die interfaces, and overhaul HBM-based dies. The new Marvell die-to-die HBM interface will have a bandwidth of 20 terabps per millimeter, 2.5 terabyte per sec per millimeter, which is a significant increase over 5 terabps per millimeter, 625 gigabyte per sec per millimeter that HBM offers today. Based on a slide of the company analyst today published by Serve the Home, over time Marvell envisions a bufferless memory with 50 terabps per millimeter, 6.25 terabyte per sec per millimeter. The Marvell does not specify how wide its HBM interface will be. Marvell does not disclose many details about its custom HBM solution, except saying it is enhanced the XPUs by the serializing and speed up the I/O interfaces between its internal AI compute accelerator silicon dies and the HBM-based dies, which somewhat implies on a narrower interface width compared to industry standard HBM3E or HBM4 solution. Yet it looks like a CHBM solution that will be customizable. Enhancing XPUs by the Italian HBM for specific performance, power, and total cost of ownership is the latest step in a new paradigm in the way AI accelerators are designed and delivered, said Will Chu, Senior Vice President and General Manager of the Custom Compute and Storage Group at Marvell. We are very grateful to work with the leading memory designers to accelerate this revolution and help cloud data center operators continue to scale their XPUs and infrastructure for AI era. Working with Micron, Samsung, and SK Hynix is crucial for successful implementation of Marvell CHBM as it sets the stage for relatively widespread availability of custom high bandwidth memory. Okay, next one is it's quite the old one. Oh, Chips Week. Except for AI and memory. The December 2024 WSTS forecast called for a strong 2025 semiconductor market growth of 19%. However, the strength is limited to a few product lines. Memory is projected to grow at 81% in 2024. Logic is expected to grow 16.9%. The micro product line should show only 3.9% growth, while the discrete optoelectronics and sensors and analog are all projected to decline, said Semiconductor Intelligence. If the memory product line is excluded, the WSTS forecast the rest of semiconductor market in 2024 is only 5.8%. The strength of the memory in 2024 is also reflected in semiconductor company revenues. Revenue for the first 3 quarters of 2024 compared to earlier show gains of 109% for both Samsung Memory and SK Hynix. Micron Technology is up 78% and Kioxia is 54%. The strongest growth among major semiconductor companies from the NVIDIA, up 135%. NVIDIA's strength is due to its AI processors. NVIDIA's revenue also includes memory purchases, adding to adding to its revenue. The strength of the memory is largely driven by the memory for AI application. Prices for memory have increased in 2024, especially for DRAM. TrendForce estimated the average DRAM prices will be up 53% in 2024. One application, AI, is accounting for the most of the growth of the first 3 quarters of 2024 compared to the same 3 quarters of 2023, shows a 97% gain for memory components and 135% gain for NVIDIA. The total semiconductor market was up 19.9% for this period. Excluding the memory components, the remainder of the semiconductor market was up only 6.8%. If both memory components and NVIDIA are excluded, the rest of the semiconductor market declined 10.5%. Several major semiconductor companies experienced revenue decline in first quarter, 1Q 2024 through 3Q 2024 versus a year earlier. ST Microelectronics and Analog Devices were each down 24%. Texas Instruments and Infineon Technology and XP Semiconductors and Renesas Electronics also declined. These companies are largely depending on the automotive and industrial sectors, which have been weak in 2024. The companies heavily dependent on the smartphone market showed revenue increases, with Qualcomm's IC business up 10% and MediaTek up 25%. Among the computer-dependent companies, Intel was flat and AMD was up 10%. Broadcom counts on AI for a significant portion of its revenues. Its calendar Q3 results have not yet been released, but it should be up about 47%. Thus, except for AI and memory, the semiconductor market has been weak in 2024. Semiconductor Intelligence's forecast of 6% growth in the semiconductor market in 2025 assumes some strengthening of the core markets of the PCs, smartphones, automotives, and industry. The rapid growth rates of the memory and AI in 2024 should be significantly lower in 2025. So the memory has long exacerbated the cycles of the semiconductor industry. The chart below shows the annual change in the semiconductor market based WSTS data through the 2023 and the WSTS forecasted for 2024. Total semiconductor is compared with the memory and semiconductor excluding the memory. While the memory market has shown an extremely of the 102% growth and a 49% decline, the market excluding memory has been somewhat more stable, ranging from the plus 42% to minus 26% in the last 10 years. The memory market changing the range. It ranges from the plus 81% in 2024, minus 33% in 2023, while the market excluding memory has ranged from the plus 25% to minus 2%. So over the last 40 years, whenever the memory market has grown over 50%, it has been a significant deceleration of the decline in the following years. And the 6 times has occurred prior to 2024. The memory market has declined in the following years 4 times. In 2 cases, the market has been positive, but a significantly lower growth of the following year and a decline 2 years after the peak. This trend is driven by basic supply and demand for a commodity product. The memory prices and production rise when supply is below demand. When a supply is above demand, the production and prices fall. So we should expect a significant downturn in memory market either in 2025 or 2026. Thank you for your time and see you next time.